Hello students. Last time we have studied about de Broglie waves after the name of the scientist G. Broglie. He assigned wave nature to particles. A particle of mass m moving with velocity v has associated with it a wave of wavelength lambda is equal to h by mv, where h is Planck's constant, m is mass of the particle and v is the velocity. Now, if E is the energy of the particle and the wave associated with it has frequency nu, then the energy of the particle is also defined in quantum theory as E is equal to h nu, or nu is equal to E by h. Also, there is another relationship, Einstein's mass energy relationship, E is equal to mc square. Now, if we put mc square is equal to h nu, because those two are different versions of energy of the same particle, so h nu must be equal to mc square. So, we have nu is equal to mc square by h. Now, de Broglie wave velocity, which is associated with the particle, let it be u, is equal to the wavelength of the wave into its frequency, nu into lambda. That is the formula of wave velocity. So, that is equal to, instead of nu you can write mc square by h, instead of lambda you can write h by mv. This is equal to c square by v. Here this v is the velocity of the particle, this u is supposed to be the velocity of the wave associated with the particle. Now we have this wave velocity is equal to c square by v, where c is the velocity of light. Now Einstein's theory of relativity says that the maximum velocity any particle can have is the velocity of light and it is constant. So, the velocity of the particle must definitely be less than c. If this is less than c, then u will be greater than c. That means the wave will move with a greater velocity than the velocity of light. So, this result is inexplicable and unexpected result, where we have a wave and a particle. The particle is moving with a lower velocity and its related wave is moving with a higher velocity. So, it is not possible. So, Schrodinger, he took care of this and he told all this means a material particle cannot be equivalent to a single wave train, but it is supposed to be related to a group of waves superimposed on each other. Sometimes they will interfere positively, constructive interference, and form a deep amplitude, big amplitude, which is supposed to be proportional to the probability of the particle in that space. Amplitude, the wave represents the particle and the amplitude of the wave square is proportional to the probability of the particle in that wave. So, here we have a localized wave which has come out as the result of a superposition of many waves. Each wave on an average maybe its velocity is c square by v, and the group of waves is called a wave packet, and this wave packet is obtained by the group of waves superposing on each other. These group of waves are supposed to have different velocity, little bit different velocities, wavelengths, and with the phases and amplitudes also so chosen that they interfere constructively over only a small region of space where the particle is supposed to be located. As soon as the particle moves out, the waves interfere destructively and there is zero amplitude, stating that the probability of the particle being there is zero. Outside this, they produce destructive interference so that the amplitude reduces to zero. Here we have shown a wave like this. See, this is a standing wave type thing where two waves have interfered and sometimes the amplitude is zero, sometimes the amplitude is maximum, and from here to here this is the probability space that the particle can be found. So this much is called the uncertainty in the position of the particle, delta x, from here to here. Later on I will explain it in Heisenberg's uncertainty principle. Here this is a standing wave. I mean, this dotted line is the envelope and inside it there is the wave. We'll see about it later. This is the amplitude and this is the x. So here in this we have defined two velocities now. One is the individual wave velocity and the waves traveling together called the group velocity, Vg. So the wave packet which we have defined up till now has a group velocity. The individual waves forming the packet possess an average velocity which is the phase velocity, which we have found the formula to be c square by lambda. Velocity of material particle is same as group velocity, which I will prove it later for you mathematically, with physical equations and theories also we can get it. So remember that it is the group velocity that is the actual velocity of the particle as this group moves forward like this with the velocity of the particle. That is what we mean. Now here we have another complicated thing to clarify. What is complementarity of wave particle duality? You know wave particle duality. A particle can be visualized as a wave under certain circumstances and under other circumstances can be treated as a particle. Every particle has an associated wavelength with it, de Broglie wavelength, and the wave is called de Broglie wave, matter wave. Up till now we have seen that even radiation, it shows wave nature, and later on the Compton effect, photoelectric effect, black body radiation all have shown the particle nature. It contains particles called photons which have energy h nu. Energy can be exchanged only in multiples of h nu. Okay, so what was complementarity? It was Niels Bohr who defined this complementarity for us. We have seen experiments where electron exhibits wave-like nature. That was the Davison-Germer experiment, Thomson experiment, which we have studied already, and particle-like behavior in various observations, wave-like in these two, particle-like in other experiments. Similarly, when electromagnetic radiation in the form of photons interacts with matter, like in Compton effect, photoelectric effect, we have seen the particle photon hits the electron, sometimes shares its total energy or sometimes part of its energy, and sometimes only the electron is released and sometimes both electron and photon are released. Okay, that's a long story we have already been through. So here we have seen how electromagnetic radiation behaves like particles of photons. The results resemble a particle-like collision, and wave nature of electromagnetic radiation is precluded there in those experiments. Photoelectric effect, Compton effect, black body radiation, we can treat electromagnetic radiation as a photon particle, one bundle of photon particles only. We cannot treat them as waves and arrive at a result. Whereas in interference, polarization, diffraction experiments, the bands, black bands, dark bands, the everything we have bandwidth and all we have calculated, it is on the basis of wave nature. So whenever we have seen wave nature or taken into consideration wave nature, the particle nature is eluded, avoided, precluded. Understand? And whenever particles also, they electron beam, we have seen Davis and Germer experiment, we have had a diffraction pattern. So there we cannot take the electron as a particle, we have to take it as a wave. So wherever this principle of complementarity says, after the Danish scientist Niels Bohr, the physical world presents itself in the form of various complementary pictures, no one of which is by itself complete, all of these pictures being essentially for our understanding. Now, generally the experiments with which particle and wave aspect of matter is not possible simultaneously. I mean, one of them is possible, both together at the same time is not possible in the same experiment. So an experiment is designed to measure particle properties like position, momentum of matter, and another experiment to measure wave aspects such as lambda is equal to h by p and nu, all this. When the particle aspect of matter is observed, the wave aspect is suppressed, it is precluded, it is put aside, and vice versa. Okay, same is the case with radiation. So now you have seen, this is just an explanation how to avoid the confusion that you are saying particle is a particle as well as a wave. So actually the situation in which the particle is, the effect which it is producing, all these define whether the particle is behaving like a particle or it is behaving like a wave. And also it is the instrument which we use to measure the system that also defines it. Some instruments define it as a particle, some instruments define it as a wave, but at one time you can define it only as a particle or a wave, not both. I hope I am clear. Here I have given you a brief explanation about the phase velocity and group velocity with diagrams. Here you see in this diagram, I have told you a group of waves. We have taken two specific waves. These two waves have different amplitudes, can have different frequencies, whatever. And when they superpose, what happens? See, at this point particularly, this wave is pulling the particle up, this wave is pulling the particle down simultaneously, so the total is zero. They interfere destructively here. For example, here you see this wave is pulling in one direction, and this wave is also pulling in same direction, so they add up, and then you will have a big amplitude, big amplitude oscillation. So this we have studied at intermediate level in standing waves also. Now this is the envelope which represents the variation of amplitude of the wave. Actual wave is this one, varying in amplitude. Now how its amplitude varies is defined by the envelope. The envelope also defines the particle position. These two waves associated with the particle superpose and give us an idea about the particle position. So here this wave is called wave packet, and this particular standing wave velocity is called wave packet velocity or group velocity. That's what I have written here. This is the phase velocity, rate at which the phase of the wave propagates in space. See, this is a simple wave, sine wave. Now the distance between two consecutive points on the wave which has same phase. Phase means what? The angle which it makes with the equilibrium in simple harmonic oscillator you have read. So from here to here, this is one wave, and from here to here the phase changes from 0 to 2 pi. This is pi, and this is phase pi by 2. Again this is also phase pi by 2 plus pi by 2. This is minus pi by 2. So therefore here and here the phases are same, and therefore the distance between two consecutive points having same phase is lambda, and the time taken for the wave to progress from here to here is called t. That is the time period you have studied in simple harmonic oscillation. Here it is the rate at which the phase of the wave propagates, that is called phase velocity. This is the velocity at which the phase of any one frequency component of a group of waves travels. It is equivalent to saying that it is the path difference between 2 points of the wave having the same phase divided by the time period. That is, velocity is always equal to dx by dt formula. So the distance traveled is lambda, time taken is t. So it can also be written as 2 pi by t, 2 pi by lambda, divide and multiply by 2 pi, you will get omega by k. So this is the formula we use here generally, because k is called wave number. It is also called propagation constant, and omega is called angular velocity, 2 pi nu angular velocity. Now what is a group velocity? It is the velocity with which the overall group of waves, that is the envelope of wave amplitudes, known as the modulation or envelope of waves, propagates through space. It is the velocity with which the energy in the group, wave means nothing but energy transmission, remember, okay? And we can't see a wave like that unless it is a mechanical wave, of course. So the velocity with which the energy in the group is transmitted, it is also defined as the rate of variation of angular frequency. I'll tell you why it is defined as the rate of angular frequency with respect to wave number. Vg is equal to d omega by dk. How it comes later on in the next question, I'll tell you. If omega directly proportional to k, supposing, means as omega increases, k increases, then Vg is equal to Vp. Both are same. So all waves are moving in phase, no distortion, nothing. Okay, the wave gets distorted as it propagates. This happens for electromagnetic waves moving in vacuum. No, Vg equal to Vp, distortion is very less actually. I'll come to it, come back to it. Check out. So now we have derive a relation between group velocity and phase velocity. Now here I have shown two waves. One is traveling and other is also traveling, but different frequencies, different amplitudes almost same. So here we have taken two waves. One y1 a sin omega 1t plus k1x, y2 equal to a sin omega 2t minus k2x. So superposition gives y is equal to y1 plus y2. That is this one, a sin omega 1t minus k1x plus a sin omega 2t minus k2x. So it will give you it will give you a is common, of course, but sin a minus b, no, this derivation, it will be cos omega 1 minus omega 2 by 2 into t minus k1 minus k2 by 2 into x, sin of omega 1 plus, it is sin a plus sin b actually. Sin a plus sin b is equal to 2 cos a minus b by 2 sin a plus b by 2. That is the whole thing. So here plus comes, omega 1 plus omega 2, here minus comes. So you can see that here I have written, okay, 2 cos a plus b by 2 sin a plus b by 2. So this part which does not have the component, it is omega, this part is called amplitude. The whole wave actually is a sine wave, as you can see, and this part is the amplitude of the resultant wave. Now the amplitude contains x as well as t. It means the amplitude is also moving. Amplitude means maximum displacement. Here you see, this is the maximum displacement, this part, the resultant wave here. this resultant wave amplitude, this is the amplitude of the resultant wave, maximum amplitude of the resultant wave, and this wave will keep on moving like that. So that is what is saying here. The amplitude contains both t as well as x, means it is varying with t as well as x, with position as well as time, and this is totally a sine wave. The resultant wave will be a sine wave. Y is equal to a sin omega dash t kx. Omega dash is angular frequency of resultant wave. Here you have seen, instead of omega dash it is how much? Omega 1 plus omega 2 by 2, and a is the amplitude, as I have told you. The amplitude of wave group is modulated in space and time by an envelope of frequency omega 1 minus omega 2 by 2. This is the envelope, and its frequency is omega 1 minus omega 2 by 2. It is also a wave, no? It will have a frequency. And propagation constant k. K is your wave number, as well as defined as k is equal to 2 pi by lambda, and it is also a propagation constant. The expression for group velocity with which the envelope moves, Vg, is again equal to difference d omega by dk. That is omega 1 minus omega 2 by k1 minus k2. So here you are dividing these two. The amplitude of the wave has a frequency and propagation constant. So frequency by propagation constant will give you the total velocity of the envelope. That is the group velocity. So 2 will cancel. So here omega 1 minus omega 2 can be written as small variation in omega, d omega by dk. It should be dk, it should not dt, dk. Vg is here dk. I have written it for you. I'll send it to you, don't worry. So now the relation between group velocity Vg and phase velocity Vp. So now what was Vp? Omega by k. So you take omega from here. What is d omega? You differentiate it, because we need for Vg d omega, no? So we are differentiating d omega from here, putting in that. So d omega will be equal to d of Vp into k plus, this is first function into differential of second function into differential of first. So you will have d omega by dk, divide this by dk, then you will get d omega by dk is equal to dvp by dk into k plus vp into dk by dk. So it will get only vp here. So I have written vp here and k into dvp by dk. Okay, so dvp by dk is again rearranged here. This is vp plus dvp by dk should give you divided by lambda and into lambda if you make. So d lambda by dk. What is d lambda by dk? See, k is equal to 2 pi by lambda. So lambda is equal to 2 pi by k, and d lambda will be equal to 2 pi by dk. D lambda will be equal to how much? Minus 1 by k square, 2 pi into 2 pi dk. So that dk will come here. So you have d lambda by dk, you put here, so that you will get vp plus k into dvp by d lambda into, you will get minus 2 pi by k square. That's what I have written here. Vg is equal to vp minus 2 pi by k square into k dvp by d lambda. So Vg will be equal to vp minus lambda here, no, vp minus 2 pi by k is lambda, 1 k will go, 2 pi by k is lambda. So lambda into dvp by d lambda. This is the relation between group velocity and phase velocity. Now keeping all these things in mind, we shall proceed to an important discussion, which gives you the general relation between how Yeah, I have also another thing I have to discuss here is the different cases. So case 1 actually deals with dVp by d lambda equal to 0. So if phase velocity of component wave is independent of wavelength lambda, then Vg equal to Vp, which is the case of electromagnetic waves in vacuum. The wave packet moves with the velocity of component waves in a non-dispersive medium. There is no distortion there. So case 2, dVp by d lambda greater than 0, then Vg is lesser than Vp. Vg is lesser than Vp. Phase velocity of component wave increases with increase in lambda. Okay, so this is Vp is increasing with increase in lambda. So dVp by d lambda is positive. So that gives, when you put in the equation, you will get Vg less than Vp. So group velocity is less than phase velocity. That is the propagation of electromagnetic waves in transparent medium. And the group velocity is less, and other velocity in glass, water, group velocity is less. And a third case where this is negative, that means as Vp increases, lambda decreases, or lambda decreases, Vp increases. So Vg will be greater than Vp. If phase velocity of the component wave increases with a decrease in lambda, then group velocity is more than phase velocity. That is the propagation of electromagnetic waves in ionized media. In ionized media, what happens? The group velocity is more and phase velocity is less. Now I'll come down to an important concept question, which is still related to, I just given it a simple heading like de Broglie matter waves, right? About de Broglie matter waves. Now we will see the approach where you have defined, how you have defined the group velocity and phase velocities. Here, de Broglie hypothesis, as you know, is concerned with a particle, material particle, being assigned a wave whose wavelength is lambda is equal to h by p. H is your Planck's constant and p is your momentum, mv of the particle. V is the velocity and m is the mass. So here if you can find the value of h, later on we'll use it, h is equal to lambda mv. Now also the energy of this particle according to Planck's theory should be h nu. So E is equal to h nu equal to mc square, Einstein's relation, Einstein's mass energy relation. So from here we take nu, supposing mc square by h, and put the value of h from here, lambda mv, we will get c square by lambda into v. Now take this lambda here and multiply. Nu into lambda will give you the velocity of the wave, which is nothing but the phase velocity, we have already called it. If this wave velocity, if this wave were to represent the particle, we have seen the controversy there that this velocity of the particle always less than c according to theory of relativity. So this velocity, wave velocity, should be greater than c, and that means the wave is traveling ahead of the particle. Here I have shown, here this is the particle supposing, and this is the wave, a wave moving ahead of the particle. Particle velocity is less than wave velocity. So wave moving ahead of the particle is meaningless, because that wave representing the particle cannot, it should be associated with the particle anytime. So we should also be localized, because particle is sometimes localized, low velocity, high velocity. Wherever the particle is, the wave must be there. So the single wave being associated with the particle doesn't work out. Since the theory of relativity, I have explained the same thing here, which we have been dealing with later. Velocity of wave, which should be representing the particle, should be move with the particle, should be equal to the particle velocity. This problem was solved by considering a material particle to be a packet of waves. Wherever the waves interfere constructively, the particle is supposed to be found there. The superposition of these waves gives us the probability of existence of particle with an uncertainty delta x within the envelope. See, here again I have given a rough example of two waves, superposition of which gives a standing wave called a localized wave, where energy is localized between these two particles. What is the importance of standing waves is the energy here is 0, the energy here is 0, and the energy is here only. So the particle energy is related to the particle, so it must be localized, like, and the uncertainty of particle found is delta x. According to the Heisenberg's uncertainty principle, we will use it, so I have defined it here. Now this is the wave envelope, and the particle moves, so the wave envelope must also move, so that is the group velocity. See, that is what here I have written. The superposition of these waves gives us the probability of existence of the particle with an uncertainty delta x within the envelope. Let such a localized wave be represented by xi xt. One dimension we have chosen, xi xt. This function should be single valued and result of interference of a group of waves, and should have maximum value amplitude. Its amplitude is denoting the probability. Amplitude square is proportional to the probability of the particle being there. So the amplitude where the particle is must be maximum at that point. So then only the meaning of the wave is understood correctly. Now let us see this in equation. Let delta x be greater than or equal to 1 by delta k. Delta k is propagation constant. K is propagation constant. Delta k difference in propagation constant. Delta k is uncertainty in propagation constant. K is actually 2 pi by lambda wave number. Now delta x into delta k greater than 1 equal to 1, and if you multiply h cross here, this equation holds. Now you see that uncertainty principle, what does it say? Delta x delta p greater than or equal to h cross by 2. A similar equation we have got here. If we see these two, here delta p and here delta k h cross, and put delta p equal delta k h cross. H cross is nothing but h by 2 pi. Delta k is nothing but 2 pi by delta lambda. So delta p will be h by delta lambda. So keep this in mind. Delta p equal to h by delta lambda is nothing but de Broglie equation. You must see that once you are replacing here delta p with delta k h cross, you are coming back to your de Broglie equation, where lambda is equal to h by p, p is equal to h by lambda, delta p is equal to h by lambda. Same equation you have got here. So this equation must be correct, and it will lead to your Heisenberg's uncertainty principle. Now we can write delta x delta p greater than or